Hi, boys and girls. It's Miss Manning. Today we are working on Module 5, Lesson 14, where we're learning to solve real-world problems involving area of figures with fractional side lengths using visual models and equations. So that's a lot of words to basically say we're working on word problems with area, and our side lengths are going to be either a mixed number or a fraction or a whole number. And they've drawn pictures and things like that for us to kind of represent them as equations. Now, in my class, we have a whole list of things that we do every time we come across a word problem. The first one is to identify the parts and the whole in the word problem. Once you read it, that's our first step that we always do. And then we always go straight into drawing a tape diagram. This one is not necessarily tape diagrams because we're using the visual models for area, and in a lot of the problems, they've drawn a picture for you. You also then have to figure out what your equation is going to be, and you use the parts and the wholes to determine your equation. And remember, area is length times width. And then you write your answer as a statement, and then go back and check it. Check your multiplication, make sure it makes sense, that if you're multiplying 20 and 1/4 times 2 and 2/3, that you're going to get an answer bigger than at least 40. So you just got to check your reasonableness in your answer the best that you can. The other thing that I suggest is this video is going to be a little bit longer than all of them. So I suggest you sit down with your problem set and you try solving out as many as you come across that you can, or try solving them, and then go back through the video problem by problem, watching how I chose to solve it, how I chose to do it. I don't give you all of the answers. Some of them I'm leading you to how you would solve it. So you can go back in or through the video problem by problem after you've sat down and tried to figure out how you would solve them. So you don't have to watch this whole video and then pull out your problem set. I would suggest working on the problem set with the video, or trying the problem set first and going back and scanning the video to find the problem set number that you're on. So I decided to split up this lesson. So for today, you have 3 word problems that you're going to be solving. Problem set number 1, 2, and 3. You won't have an exit ticket for today, but then tomorrow we'll be finishing up with the last 2 problems of this problem set, as well as your exit ticket. The very first thing that we need to do is identify the part and the wholes of this problem. So if we're reading through, George decided to paint a wall with 2 windows. Both windows are 3.5 by 4.5 rectangles. Find the area of the paint needs to cover. So if we are thinking about our part and our whole, we could do several problems here. I could identify the area of this wall as a whole, which would make the 12 and 7/8 feet part of it, and another part would be the 8 feet. So that could be one that we have. We could also say the area of the windows is our whole, or area of one window. And so one part of that would be 3.5 feet, because that would be the length or width. And the other part would be 4.5 feet, because that would be the other side measurement. But there's 2 of them, so we would have to double this. We could also talk about the idea of having part and a whole of the total area of our window, or of our wall, as being the whole, and the part being the area of the windows. I'm going to underline that S because it's important to know that there's 2 of them. These are 2 windows here. If I was building this wall and I said to put in 2 windows, what you would do is you would cut out those windows right here. And it's the same thing with paint. When we're painting this wall, we're not going to paint over these windows. That's not how you do it. So we have to take the area of those windows out, just like we would cut it out of a wall. So for us to solve this, we have to take the area of our windows. Nope, just kidding. The area of our wall, sorry. And we have to subtract the area of the windows, 2 of them. Our next step would be to draw and label our tape diagram. Well, they've already given us a picture here. All we have to do is label our windows, which are 3.5 feet by 4.5 feet. And both of them are the same size, same rectangle. Our next step is to write our equation and solve it. So if our area of the wall minus our area of the windows. So first we've got to figure out the area of our wall. To do that, we do 8 times 12 and 7/8, or 12 and 7/8 times 8, doesn't matter. The commutative property says that we can switch those around. So first, let's switch this guy into an improper fraction. So we need 12 copies of a whole with a denominator of 8. So that would be 8/8 plus our leftover 7/8. So 12 times 8 is 96/8 plus 7/8 is 103/8. So then I'm going to bring it down here and I'm going to say 103/8 times, well, I'm going to put it on the other side, times 8. And here's the thing that's going to be really cool about this. When I have this fraction bar, it means to divide. And what am I dividing by? My denominator, which is 8. And then I have my multiplication symbol multiplied by 8. So I have 103 divided by 8 times 8. And essentially, dividing by 8 and multiplying by 8 end up canceling each other out. I'll prove it to you. If I had 6 divided by 2 times 2, so I'm dividing by 2, but I'm also multiplying by 2. 6 divided by 2 is 3, and 3 times 2 is 6. So essentially, those canceled each other out. It's the same thing if I said 6 minus 2 plus 2. That might be easier for you guys to look at that and be like, well, if you're taking away 2, but then later adding 2, it's the same thing. It's the same thing with dividing it into 2 groups and then making 2 more copies of it. They're counteracting each other. So I don't actually have to solve this one out. I can cancel out dividing by 8 and multiplying by 8, which means I'm left with an area of the wall of 103 feet squared. So the area of the wall is 103 feet squared. I don't know why I made feet so small. And then we have to subtract it from the area of the window and the area of the window. For number 2, when we're identifying our part and our whole, we have Joe using square tiles. That's important. Some of which he cuts in half to make the figure below. Each square tile has a side length of 2.5 inches. What is the total area of the figure? So the question is the total area, so that's my whole. Not just the area of one of the squares. The other thing is this idea of this triangle here and this triangle here. When you would slide this one around, put those two together, you end up with one total square. This triangle, along with, sorry about my drawing, this triangle gives me another square, and this triangle down here with this other triangle gives me a third square. But that's not it, because I also have fourth one, fifth, 6, 7, 8, 9, 10, 11, 12, 13. So one of my parts is my 13 squares, or tiles, square tiles. But I also have another part because I don't know the area of the tiles. The area of one of these. So to find the area of one of my square tiles, I have to take the length, which is 2.5 inches. And remember, it's a square, so the length and the width are going to be the same. So when I multiply that, I'm going to end up with the area of one square tile. So that's the area of one of my tiles. But remember, the other part is that we have 13 square tiles. So to find my total area, the area of all of this figure, or the tiles, total area, I don't know why I said area, there we go, okay, is going to be the area of a tile, and then how many copies did we have? We had 13 copies. So you've got to find the area of the tile and then make 13 copies of it before you know the total area for number 2. So for our problem number 3, it's all-in-one carpets, is installing carpeting in 3 rooms. How many square feet of carpet are needed to carpet all 3? So essentially we need to figure out all 3, but we kind of have 3 smaller problems here. We have partner holes first. So I'm going to just look at room A. The part would be the length, which is 25 and 1/4 feet long. And then the other part would be this 15.5 feet wide. And the hole would be this area of room A, which we don't know. So it's a big question mark. Then we have another room, room B, which I have a part of 18.5 feet. That would be our length, and our width of 19 feet. Ooh, sorry, that's a little hard to read. 19 feet. And the hole in this case would be the area of room B, which we don't know yet. And then we have room C. We do know the width, which is 16 3/4 feet, but what we don't know is the distance from here. But they've given me this side length and this side length. And we do know the total for room A. So if I were to draw this as a tape diagram, I'm going to try to make this the same length as room A. Draw a tape diagram. My kids know how much I love a tape diagram. So right here, the distance from here to here is 2 1/4 feet. The distance from here to here is 2 feet. And the distance from here to here is a question mark. So you're saying, I don't know how I'm supposed to solve this, but remember, we do know the total length of this whole thing. This whole thing was 25 1/4 feet. So in the same way, if I gave you a tape diagram that said that the total of this tape diagram was 6, over here was 2, and over here was 1, what's this space? You would be able to figure that out. You would take 6 minus 2 minus 1, and you would say this is 3. So that's essentially what we're going to do, but it's just with more intimidating numbers because we have fractions thrown in. So 25 1/4 minus 2, well, that's pretty easy. That's 23 1/4. And then we have to take away 2 1/4 from that. So we can end up figuring out the length of room C. So 1/4 minus 1/4, well, that's nothing, that's 0. And then you have 23 minus 2, which is 21. So the length of room C is 21 feet. So I can come down here and label my part, and then my hole is the area of room C. So once I find the area of all of those different spaces, the area of room A, the area of room B, the area of room C, my hole would be the total area. And the parts for this would be the area of room A, area of room B, and the area of room C. So then what are we going to do when we have all of those areas so we can find the total area? Well, you're going to be adding them together. So you need to take area of room A plus area of room B plus area of room C, and that will give you your total area for the carpet for all three of those rooms.